Question 8. Use the graph to calculate the acceleration due to gravity on the moon. So if we look at the graph, it's a velocity time graph, and the gradient of a velocity time graph gives us the acceleration. From your maths lessons, hopefully, that you can remember that the gradient is equal to the rise over the run, which is the change in y over the change in x. Because we're starting from the origin, it's quite easy to see the change in y. It's just up to this point here, the change in y is 2 meters per second, and the change in x, well, we need to look at that carefully, don't we? Okay, there's 1.3 there, so each of these small squares is worth as 0.02, so that means that the time is 1.26. Work that on a calculator and we get the answer 1.6 units of acceleration meters per second squared. So for a perfect answer, that's what your working out would look like in the space that they've provided. 8 part 2, use the graph to calculate the height the hammer was dropped from. Again, we need to go back to the graph, and you should know that for a velocity time graph, that the connection to distance is the area under the graph. The area under this graph is given by the formula for the area of a triangle, so half times base times height. The base of the triangle, as we've said previously, is 1.26. The height of the triangle is 2, and a half and a 2, when you multiply them you get 1, so the answer is just 1.26 meters. And there you can see my answer written into the space that they've provided. Part B, the gravitational field strength is smaller on the moon than on the Earth. Suggest why. The answer is that the moon has less mass than the Earth, and that word there, mass, is underlined in the mark scheme, which means that it's essential to have that word in there for the answer. If you just said that the moon is smaller than the Earth or anything like that, then that wouldn't be the correct answer. Okay, it's gravitational field strength is caused by masses. Okay, so it doesn't matter how big things are. Things can be quite small, but have a very high mass and have a very large gravitational field strength. Like Part C, they're asking why, if you did the same experiment on Earth, why the feather would reach the ground after the hammer, even though the force of air resistance is smaller on the feather than on the hammer. Explain why it reaches the ground first. The first thing that maybe needs explaining is this bit here. Even though the force of air resistance is smaller on the feather than on the hammer, there's two things that affect air resistance, and if you put your hand out in front of you, you'll be able to work these two out. If you move your hand backwards and forwards slowly, then the air resistance is low. If you move it quickly, then the air resistance increases. Now do the same holding your textbook, and what you should feel is, because you've increased the surface area, that now there's a bigger force of air resistance pushing back. So it depends on two things. It depends on the velocity, and it also depends on the surface area. So in the question, they're saying that the force of air resistance is smaller on the feather than on the hammer. So I guess we can deduce from that that the feather must be smaller, have a smaller surface area than the hammer. Okay, so now that we've got that out of the way, we need to see if we can explain what our answer is. So my first bullet point summarises that point. As both the feather and the hammer fall, accelerate towards the ground, their velocity will increase, and therefore the air resistance on the feather and the hammer will increase. Second bullet point is that the feather has less mass than the hammer, and therefore it weighs less than the hammer. Hopefully my little diagrams here will help to explain the next point, and this is a good tip for when you're in an exam. A picture is worth 1,000 words, so really I would strongly encourage you to draw little diagrams whenever you can, because it makes it very clear what you're trying to get across. You can see here that here's the feather, and the weight is considerably less than the weight of the hammer, but because they're falling and they're both accelerating, the air resistance is getting bigger in each circumstance. But of course, for the feather, the air resistance is going to be equal to the weight much sooner in the fall than for the hammer. And of course that means that when those two forces are balanced, that the resultant force for the feather is going to be equal to 0, which means that from Newton's second law, that the acceleration is going to be equal to 0, which means that at that point it will have reached its terminal velocity much sooner for the feather than for the hammer. Which brings us to the final point, that will mean that the time for the feather to drop is going to be greater for the feather.